Hi friends, as we have discussed the applications of amplifier in the last video about inverting and non-inverting amplifier. So today we are going to discuss the third one, that is the about integrator. So first we'll see some points of about integrator. A circuit in which the output voltage waveform is the integral of the input voltage waveform is the integrator. Second point, such a circuit is obtained by using a basic inverting amplifier with resistor R1 and the capacitor C1 as shown in the figure. You can see here, this is the inverting amplifier. Generally, whenever we are discussing or whenever we are talking about integrator, we are not using the RF. RF is used for the practically used. So whenever we are using the RF, this is used for the practically, not we are using the normally RF. So this is the basic diagram for the integrator. This is, as we have, as in the last video told you, that the positive supply, negative supply. This is the diagram for the integrator. This is the input voltage RF, R1 is the capacitor, CF means feedback capacitors, and this one we have to find out, means V0 is equal to -1 by RF R1 CF integration of limit from 0 to 2 VIN dt plus C. So we have to find out. Here negative sign shows that op-amp is an inverting amplifier. Op-amp is an inverting amplifier. As I have told you, why you writing here 0 voltage means this is from the virtually ground concept. We can write here 0 voltage. So let us try to derive the expression for V0 that we have written here. Let us see. First, see here, the expression for the output voltage can be obtained from the KCL, Kirchhoff's current rule, written as node X as follows. We know that from the KCL how much the current is going is should be equal to the output input is equal to input current is equal to output. So I in is equal to IF. We know that in the case of IC, we can write here IC is equal to C dVc by dt. So we know that we can write like that in the terms of the derivations of the voltage with respect to time. So input voltage, input current IN is equal to VIN minus 0 by R1. Yes or no? Means from the diagram, from diagram you can write here input VIN, this is the VIN minus 0 from that we have written from the virtually ground concept that minus 0 by R1 is equal to CF means IF. We can write because here we have written the capacitor CF, this CF. So IC is equal to C dVc by dt. So CF derivation d of 0 minus V0. So because here we have written 0 minus output voltage by dt. So dV0. So from there, from whenever we'll rearrange the above expression, then we can write here dV0 by dt is equal to -1 by R1 CF dot VN. Yes or no? So we know that whenever we are integrating now we have to integrate the both sides. So whenever we are integrating the derivation dV0 by dt integration term, it will be equal to V0. So it became V0. So here -1 by R1 CF, this is the constant, so we have taken outside. So we have taken the limit from 0 to t, that V on dt plus some constant plus some constant. So we have derived the derivations for the integrator. Now we can see here input and output waveforms of integrator. So whenever we are giving the square waveform in the input, then we are getting the triangular wave in the output as shown in the figure. So suppose this is the triangular, we are giving the triangular waveforms, no sorry, we are giving the square waveforms here, then the output will get as the triangular waveforms as shown in the diagrams. So this is about integrator. Thank you.